So last week we finished up talking about the mole, and we said that the mole is a counting tool for chemists. And in particular, we said that 1 mole is equal to 6.022 times 10 to the 23rd things, right? Does anybody remember the chemist that came up with this number? Avogadro. He's a funny-looking guy. I meant to put a picture on here of him. And we said that it's an incredibly large number, so it's typically used to count very tiny things, but we did a warm-up problem where we converted the population of our planet to moles of people. And then we started talking about molar mass, and we said you can use the periodic table to determine the molar mass of individual elements, which is the same as the AMU number, or you can use it to determine the molar mass of an entire compound, where you have to take each individual element, determine how many of each element you have, and then add up all of the AMU numbers to get your molecular weight in grams per mole. So we did a couple of these, and today we're going to be doing a lot more of this. So let's talk about mole relationships. And we're going to just break it down into individual steps, and then we'll jump into our worksheet. So the first one we have is mass to mole conversion. And these are pretty straightforward. So let's do the first one. So the first one is how many moles of W? Does anybody remember what W stands for?
Water.
Not water. And 9.25 grams of W. W is for tungsten. If you look at the old incandescent light bulbs, that curly Q on the inside is tungsten. It's a really dense metal. There's also a really cool book, if you like reading about science, called Uncle Tungsten. It's by Oliver Sacks, a really famous scientist and doctor who just passed away last year. So let's go ahead and do this math. And like I said, we always want to start out with what we know. So we know that we've got 9.25 grams of W. We need to cancel out grams, so that's going to go on the bottom. And we want to determine how many moles we have, so we'll put that on top. That makes sense. So grams. All right. What's the molecular weight for tungsten? What do you guys think? Yeah, 183.8. Does that go on the top or the bottom? On the bottom, so it's grams per mole. So it'd be 183.8 grams of tungsten for every 1 mole of tungsten. Okay, and if we plug this in, how many sig figs should we get out? 3, right? So if we plug this into our calculator, we should get 0.0503 moles of tungsten. And I really like to box my answers with these problems, that way I can keep track of where I'm at. Does that make sense? Let's try a harder one. So how many moles of CaCl2? How would we name that?
Calcium chloride.
Do we do calcium dichloride or just calcium chloride? I heard 2 answers.
Calcium chloride.
Is it covalent or ionic? What do you guys think? It's ionic, so we don't use mono, di, tri, tetra. So this would just be plain old calcium chloride. So how many moles of calcium chloride are present in 5.44 grams? So I'll give you guys a minute to work on this, but check with your neighbor and see if you guys are coming up with the right number. And we're going to set it up the same. So we need grams on the bottom, we need moles on the top. We're going to cancel out grams, and we should be left with our unit of moles. Is calcium chloride on the periodic table? No. We probably have to do some math to determine its molar mass. So the molecular weight of calcium chloride We've got 1 calcium, so I'll do 1 times 40.078. We've got 2 chlorines, so 35.453. This gives us a molar mass or molecular weight of 110.98 grams per mole. Should that number go on the top or the bottom? On the bottom, right? So that's grams per mole. So 110.98 grams per 1 mole. All right, and that gives us 0.0490 moles of CaCl2. Does that make sense? A lot of this is just basic math when conversions.
Wouldn't it only be like 0.09?
So in this case, we need 3 sig figs. So our 5.44 has 3 sig figs, which means our final answer also needs to have 3 sig figs. If we look here, because it's a trailing 0 after a decimal point, we have to include that trailing 0. Does that make sense?
So the one after, like the first 0 was a 0.
Yeah, exactly. These zeros up here don't get counted for sig figs because they're leading zeros. Trailing zeros count if you have a decimal point. So in this case, this has 3 sig figs, and this has 3 sig figs. We need to make sure that they match. That's a good review. All right, now let's do the opposite. Let's go from moles to mass. This is similar, so let's do an easy one first. So, what is the mass of 3.79 moles of Xe? What is Xe? It's a noble gas, it's xenon, so it's found in a lot of the signs that light up. And let's try to convert this. So we've got 3.79 moles. So what unit should go on the bottom now? Moles, okay, and that means grams should be on the top. All right, so if we look at the periodic table, xenon has an atomic mass of 131.3. Should that go on the top or the bottom? Top. And that's per 1 mole. We cancel out our moles, and we're left with our desired unit of grams. Does anybody want to help me out with the math here? 497? Okay, so 497 grams of Xe. Make sense? The biggest obstacle I see students running into is they put the 131.3 on the bottom instead of the top. So make sure you're keeping track of where the mass number is at. The larger number should go with the grams. All right, let's try a harder one. So what is the mass of 0.467 moles of glucose? And glucose is C6H12O6. It's one of our simple sugars. It's used a lot in biology. And again, we always start with what we know. What should we do before we do any unit conversions? Yeah, I'd agree. We should find the molar mass of glucose before we get too much further. So I'll say, all right, the molecular weight of glucose is 6 carbons. Carbon has a mass of, 12.01. We've got 12 hydrogens. So that'd be 12 times 1.008. And then we've got 6 oxygens, which is 16.00. What was the mass, or the molecular mass for glucose here? 180.16. Okay, so we'll go ahead, we'll put moles on the bottom like before, grams on the top, and does 180 go on the top or bottom? Top. Cancel out our moles, and we're left with our desired unit of grams. Does anybody have a calculator? Want to help me? 84.1. We need 3 sig figs, so that sounds good. Does that make sense? So it's pretty easy to convert from grams to moles, but now let's switch gears and talk about just simple things. So we'll switch to counting rather than moles. Okay, so let's do atoms or molecules to moles. Let's do how many moles are present if you have 3.46 times 10 to the 22nd atoms of calcium, Ca. So the only thing that we're given is that 3.46 times 10 to the 22, so we know we start with that. And we know that the unit in this case would be atoms of calcium. So we need to cancel out atoms, so I'll put atoms on the bottom. And the unit we want is moles, so I'll put moles on top. That's good because we cancel out atoms and we get our desired unit, right? Question is, what number do we need to plug in and where should it go? Yeah, exactly. So we would need to use Avogadro's number, which says that 1 mole of something is equal to 6.022 times 10 to the 23rd. And if we go ahead and do this, we get our final answer in moles. And I will say that these problems in particular, people get hung up on typing things incorrectly into their calculator. So if you're getting a different answer than me, that would be a good time to go to an SI section or come talk to me to make sure that you're typing it incorrectly into your calculator. But the correct answer for this one should be 4.15. Or sorry, I'm on my wrong problem. 0.0575 moles of calcium. Is that what other people are getting on their calculator? Is anybody getting that same number or a different number? You got the same one? Yeah, sorry. I was looking at the wrong part of my notes. Oftentimes what I do, just to avoid confusion with the calculator, is I bracket in these with parentheses, and then I bracket in Avogadro's number with parentheses too. Otherwise, it thinks that you're doing a different mathematical operator. Does that make sense? So if you are getting an incorrect number, it's always better to err on the side of caution and use more parentheses than you need. You guys getting it now? All right, that's good. All right, let's try another one. So how many moles of PCl5? What's the name for PCl5? Yeah, phosphorus pentachloride, right? We don't have to worry about Roman numerals or anything like that. This is covalent, so we do need to use mono, di, tri, or tetra. Excuse me. So how many moles of phosphorus pentachloride are present if you have 6.52 times 10 to the 24th molecules of PCl5? So again, we're going to start with what we know. We've got 6.52 times 10 to the 24th molecules. We want to cancel out molecules, so I'll put that on the bottom. We want moles, so I'll put that on the top. Do we need to determine the molar mass? No. We just need Avogadro's number. Oftentimes people make more work for themselves than they have to. In this case, we don't deal with grams at all, so we don't have to do that. And then same sort of thing. We need to plug in Avogadro's number, which would be 6.022 times 10 to the 23rd things for every 1 mole. And if you're having trouble with your calculator, make sure you put in these parentheses to keep track of things. We cancel out molecules, we're left with moles. What are you guys getting for this one?
$10.82.
10.82. How many sig figs should we have? Yeah, so we should have 3 sig figs, so we may need to do some rounding. So this should be 10.8. Phosphorus pentachloride. So remember to keep track of your sig figs when doing these conversions. It's easy to forget that. All right, you guys ready for a more challenging one? I know these get kind of boring. All right, so let's do mass to moles to atoms or molecules. So this is going to have 2 steps rather than 1. All right, so how many atoms of Pb, what does Pb stand for? Anybody know? Lead. Does anybody know the Latin word for lead? It's plumbum. If you have actually read anything about the Romans, you might have heard about their lead poisoning problem, right? So plumbing comes from the word plumbum. They used to make all their pipes out of lead, and they got pretty crazy as a result. They had a lot of neurological issues. So that's why we try to avoid lead pipes in our homes today. We don't want to look like the Romans. All right, so PB is for lead. And it says, how many atoms of lead are present in 9.25 grams of lead? So first thing we want to do is convert from mass to moles, and then we want to convert from moles to atoms or molecules. Let me scoot this over. So we want to cancel out grams first. I'm going to put grams on the bottom. And we want to convert it to moles, so I'll put moles on top. That makes sense. So now we've canceled out that, but ultimately we're asking how many atoms we have. So we need to cancel out moles and get to atoms. And if we do this, we cancel out moles on the top and bottom, and we're left with our desired unit of atoms. But now we have to plug in numbers. So over here, what numbers should go where? Yeah, the 207.2, we look at the periodic table, that's the atomic mass of lead. Should that go on the top or the bottom? The bottom, it goes on the gram side. So 207.2 grams for every 1 mole. Okay, so we've got that conversion taken care of. Now let's go over here and look at this guy. What number should go where? Yeah, Avogadro's number should go on top, exactly. So we've got 6.022 times 10 to the 23rd for every 1 mole. And like I said, I like using parentheses to avoid any confusion. How many atoms of lead do we have there? Anybody want to help me? Yeah, 2.69 times 10 to the 22nd atoms. So make sure that you keep the correct number of sig figs. We started out with 3, which means we should end with 3. So 2.69 times 10 to the 22nd atoms of lead. Oop. All right, want another harder one? All right, we'll do a few more practice ones and then we'll jump straight into the worksheet. So let's do another one. So how many molecules of CO2 are present in 34.3 grams of CO2? I'll give you guys a minute to work on this, but then check with your neighbor when you think you got it and make sure you guys have the same number and that you set up your work the same way. Another show of thumbs. All right, so let's do this as a class. We know we've got 34.3 grams of CO2. We need to cancel out grams. The only way we can do that is by converting grams to moles. So I'll put moles on the top. All right, and how many grams are in 1 mole for CO2? Probably want to figure that out, so I'll do this down here. We'll say the molecular weight for CO2. We've got 1 carbon, so 1 times 12.01, times 2 oxygens, which are 16.00. Should give you a molar mass of 44.01 grams per mole. Okay? So I'm going to plug this in on the bottom because we know that large number should go with the gram side. Now that's good because we've canceled out grams. But now we need to cancel out moles and we need to get to molecules, right? So I'm going to put moles on the bottom to cancel out the moles. And I'll put molecules up here. And we know that 1 mole is equal to Avogadro's number, which is 6.022 times 10 to the 23rd. I'm going to use parentheses to avoid math mistakes. And I'm getting 4.69 times 10 to the 23. Is that what you guys were getting? Okay, that's good. That means my calculator works. And I'll just write in my units. One pet peeve of mine, and probably for a lot of your science instructors, is when you go and solve a problem and you just give a number without units or any reference to what that number signifies. So always include your units and try to be descriptive. Let's do another one. Let's go the other way. We'll do atoms or molecules to moles to mass. Okay, so let's do another one with glucose. So what is the mass of 3.99 times 10 to the 23rd molecules of glucose? So again, try to work through this on your own and then check with your neighbor. For which one? Yeah, it's C6H12O6. Shoot, sorry. That's not glucose unless there's a 6. And I'll give you guys a hint. We just determined the molecular weight of this at the start of class. What was the molecular weight? 180.16. So you don't have to go through the hassle. Sorry about that. All right, let's try doing this one as a class. Okay, so we know for sure that we've got 3.99 times 10 to the 23rd molecules. Okay, now we need to make sure that we have molecules on the bottom. And we need to convert this to moles, right? So if we do this, we cancel out molecules, and we're left with moles. All right, what number should go where? Avogadro's number should go on the bottom. And again, I'm going to put parentheses in just to keep track. We know that's equal to 1 mole. Okay, and we know we need to cancel out moles and go to grams, so this way we can cancel out our top and bottom and be left with our desired unit. And we just said that the molecular mass of one molecule of glucose was what? 180.16. So I'll put that on the top or bottom? On the top. So 180.16 grams per mole. What number are you guys getting for this? 119.4. How many sig figs should we have? 3. So what should our final answer be? 119. All right, so what we're going to do with the remainder of the class period is work through that problem sheet that I have up front. And I want you guys to try to do this with a partner as much as possible. I saw a few of you guys over in the study room last Friday working through the problem sheet. That is exactly the way you should study for chemistry. Try to get a group of peers and work through problems together. It makes everything a lot more manageable and a lot less boring too. So try to find a study group if you can.